Alright, this is my Physics 4 lab report. The purpose of this lab is to describe oscillating spring motion and compare experimental data from an oscillating spring to predicted data for the spring's motion using coding. When comparing the predicted and experimental data, it was found that the experimental data had a slightly larger wavelength and smaller y-coordinate wavelength when compared to the predicted data. Physics principles, including Newton's second law and the conservation of energy were used. So these physics principles was the Newton's second law. The motion of a system is based on forces acting on a system. In this case, the forces are gravity and the spring force. Then the spring force is equal to the spring constant multiplied by the displacement from equilibrium. The spring force is the restoring force that makes the spring oscillate. And then the change of energy of the system is zero because the conservation of energy principle. And the experiment that was inputted into Tracker was one where a mass at the end of a vertical spring was dropped from rest. The mass then oscillated on the x and y axis through the duration of the experiment. This is a photo from that. Tracker outputted this data, which I exported into an Excel spreadsheet and isolated the X and Y values into a separate spreadsheet in order to import the X and Y position into the program. Okay, this was some of the code from GlowScript. On the left, these were all the initial conditions from the experiment, including mass, location, change in time between data points, and information about the spring, like the spring constant. On the right, at the top, this code used Newton's second law to update the position and velocity of the mass on the end of the spring. This next bit of code calculated the change in kinetic and potential energy of the system, and this last bit of code calculated and updated the spring displacement from equilibrium. This was on the left, this was the simulation outputted by the code, simulating the location of the predicted and experimental ball, the blue and red balls. And on the right, these were the graphs outputted, including a graph of the change in energy of the X and Y positions. This first graph of the X position of the predicted and experimental mass was consistent in amplitude and displacement, but the graph of the experimental mass had slightly larger wavelength. For the second graph of the Y position, the predicted and experimental mass was less consistent in amplitude, displacement, and wavelength compared to the graph of the X positions. And then some reasons for inconsistent results could include not taking into account factors like air resistance or drag of the mass in the experiment, as well as just inconsistencies in tracking the point mass in Tracker. And for the what does it mean questions, for this first question, the energy principle is satisfied because total change in energy is around zero the entire time. This is shown by the graph in the bottom left. The orange line is the change in total energy, and it stays pretty much at zero the entire duration of the experiment. And for the second question, using data from Tracker, the oscillation period estimated from the X position data turned out to be 1.5 seconds, and the oscillation estimated from the Y position data also turned out to be 1.5 seconds, and this was shown by the these two graphs in the bottom right, showing that. And yes.